Section 4.6, the counting principle. The counting principle gives us an idea or a way to count objects with a specific arrangements sometimes. So here's what the counting principle tells us, and this is the last section of chapter 4. If there are A ways to perform task 1 and there are B ways to perform task number 2, then together there are A times B ways to perform task or to perform both tasks. It's hard to understand the counting principle unless we look at a few specific examples of how we can apply this. Now, let's say if John plays on his school soccer team. The soccer uniform has two options. Let's say that the first option is the sweater, and the sweater has 3 different colors, red, white, and black. And that the short, there's also 3 different colors for the short, red, white, and black. So the question here is, how many different variations of the soccer uniform can the coach choose for each game? So remember that the sweater, there's 3 different colors for sweater, and there's also 3 different colors for black. So you can think of it as the first task 1, there's 3 different colors. That means that there's 3 ways to choose task 1. And there's also 3 ways to choose task number 2, all right, which is the short. So the counting principle says there's a total of A times B. So A is 3 in the first case, B is also 3 in the second case. So together there's like 9 ways to choose these combinations of color for the sweater and color for the short. So let me show you what I mean. So for the sweater, we know that they have 3 different colors for the sweater. So the red, the white, and the black. Okay. Now each one of these color that's chosen for the sweater, we have to choose a color for the short. So the coach might choose red for the short, white for the short, or black for the short. And let's say if he stuck with, the color white for the sweater, then once again he has to choose a color for the short. Okay. And similarly, if he chose the color black for the sweater, then he also has to choose either red, white, or black for the short. So if you look carefully, here is one of the combination that's possible. Here's another combination that's possible. Here's another combination that's possible. So if I keep doing that again, and again, we can kind of see that there is 9 different variations to choose the soccer uniform. Okay, the counting principle tells us that if there is 3 ways, so for the short, let's start with the sweater. There is 3 ways for me to choose the sweater because there's 3 different colors, and there is also 3 ways for me to choose the short. The fundamental counting principles tells us that the number of ways can be found by multiplying these 2 numbers together, which we also get 9. So we know that there's 9 ways to choose the sweater and the short as a combination of the uniform. Okay. All right. Let's take a look at another example of the counting principle. So let's say that a luggage lock opens with a correct 3-digit code. Now, if you ever look at a luggage, some luggage has a little code that can be used so that sorry, that's a terrible luggage right here, but very terrible luggage. But luggage usually has a little code usually right here, and it's usually a 3-digit code that tells you that if you enter it correctly, then you can open this case. So the question here is, remember that each wheel has a digits from 0 to 9. So how many different 3-digit codes are possible? So to address part A, we know that the first wheel, there are from 0 to 9. That means that there's 10 ways. Okay, guys? There's 10 ways for us to choose the first wheel, right? And for the second wheel, there's also 10 ways for us to choose the second wheel, because the second wheel is also going from 0 to 9. And then lastly, for the third wheel, there's also 10 ways for us to choose the third wheel. So the fundamental counting principle says that the number of ways is multiplying all these together, and therefore we're going to get 1,000 different possible combinations that we can use to secure our luggage or to open our luggage. Now, part B has a little twist to it. Part B says once a digit has been used, it can no longer be used. So for the first wheel, there will be 10 ways to secure your lock. However, for the second wheel, and what I mean by wheel is each one of these number is considered a wheel, okay? Because not one number is chosen, that means that there's 9 numbers left to choose. And if 2 numbers are chosen, then the third wheel has basically 1 number left, has 2 numbers less than the first wheel. So therefore there's 8 ways to choose the first wheel, and the total combination of it would be 10 times 9 times 8, 10 times 9 times 8, and that equals to 720 ways to choose your combination. Or there's 720 ways for you to unlock your combination if you guess. Okay. All right. So this notation right here. This is the letter N with an exclamation mark. It's a math symbol. It's called factorial notation. Whenever you see this, it means that you're going to take the products of descending consecutive natural numbers until you get to 1. I'm sure that's not very clear, so I'm going to give you an example. Let's say if you see 5 factorial, then it basically means 5 times 4 times 3 times 2 times 1. That's what it means, okay? So if you see, like, for example, 11 factorial, then it's really 11 times 10 times 9 times 8, all the way until you get to the number 1. And that's what factorial means. So whenever you see this is what it means. In general, whenever you take like n factorial, that means that you start with that number and then you multiply it by one number less than n. Usually we represent one number is less than n to be n minus 1. That's one number is less than n. And then you multiply it to one number is less than that previous number, which is n minus 2, and then you continue on this pattern until you get to the number 1. And that's what we mean by n factorial. Okay, great. Please watch the next part, and I'll talk about the permutation.